Good day. My name is Silay Brovashov, and I'm Marketing Manager in Intelligent Storage in Huawei. And today I will speak about intelligent data infrastructure and how companies can solve their data-related challenges using this infrastructure. So let's start. The rise of autonomous driving, 4K or 8K video, AR or VR, and IoT applications is driving data surges along the way. For example, an autonomous driving car may generate up to 64 petabytes of daily data in the future. 2 million cameras in Shenzhen can produce 80 petabytes of daily data. According to Huawei Global Industry Vision, or GIV report, the global data volume will grow from 32.5 zettabytes in 2018 to 180 zettabytes in 2025. Massive amounts of data pose a lot of challenges, but every challenge is an opportunity. If an enterprise cannot deeply analyze and mine mass data of production systems, the data can only be one kind of resources and may end up as a burden for an enterprise. Data is becoming more and more important to enterprises, and the corresponding data value is helping drive enterprises' operations. First, how does one understand data-driven experience? When you open an app, you will receive a push notification that attracts your attention. This push notification is driven by data. For example, Kuaishou, a well-known Chinese app, generates 120 million content labels every day to match user profiles in real time, and data operations carry out precise content push. During enterprise operations, data also drive decision-making in enterprise production. For example, after 50 years of continuous exploitation, Tagan oil field in China is facing resource depletion and reduced production. Fortunately, more new oil and gas reservoirs were found thanks to data analytics. This provides an accurate data needed for decision-making and ensures a long-term and stable production of 5 million tons of crude oil. Finally, processes in enterprises are significantly simplified thanks to the data-driven model. For example, Huawei has more than 180,000 employees that go on business trips every year. In the past, business trips involved more than 1,000 application processes that record attendance, air tickets, hotels, and reimbursements. Now, our employees just need one application process to do the job. This is the result of 450,000 joins of data every day. We can let data do the legwork. Next, let's move on to the 3 challenges of unlocking huge data value. Many industries try to figure out ways of how to quickly unleash the data value for better enterprise operations. Based on surveys in various industries, Huawei summarizes the top 3 challenges for customers in maximizing data value. First, mass data poses cost challenges. We all know high costs do no good for enterprise operations. According to the survey, the costs are mainly from the following 3 aspects. First, diversified data. Structured, unstructured, and semi-structured data coexists. Enterprises need to push sources with multiple storage devices, such as block, file, object, and big data storage devices. Then, low storage utilization. The multi-copy technology is used to ensure data reliability and low storage utilization. Enterprises need to purchase a large number of servers to meet data storage requirements. Third, high operating and management costs. To balance compute and storage, mainstream vendors often use general-purpose servers with 12 or 24 disk slots in big data scenarios. The Big Data Platform, CDH, does not support a data node with more than 100 terabytes of data. This means more space and power consumption. For example, a carrier's log retention system needs to store data for 180 days. Over 800 servers need to be added for adding 46 petabytes of data and cost tens of millions of RMB. Furthermore, more than 140 cabinets need to be added, and the annual cost of space and energy consumption exceeds 10 million RMB. There are scheduling problems using decoupled solutions. For the capacity expansion, the computing and storage resources expand linearly. This increases the cost, causes a data imbalance, and reduces the system performance and stability. For the resource sharing, the performance of systems varies significantly during peak hours. Computing resources are not shared, resulting in low average utilization. Finally, there is a weak adaptability. It takes several weeks to prepare for potential problems of service rollout. If there is any emergency leading to service surges, such as a galley event, servers and other systems need to be newly deployed or expanded. Big data is booming. From 2011 to 2020, various industries are investing in big data construction. Engineers build multiple big data systems like building Lego blocks. You may find out some disadvantages of this Lego-style big data solution over time. The first one is difficult to select components. There are many components with different development models and languages. It is difficult to ensure compatibility and avoid being bound to one component. Second, data silos. Poor interconnection between components lead to the trap of being difficult to find, fetch, and migrate data. There are also data expansion problems. The third problem is the high threshold for development. The development languages of components are different, so do the northbound interfaces. This greatly increases the development costs and technical threshold. Take a company's report of purchase, sales, inventory, or PSI as an example. The report involves 4 data sources, over 10 business systems, and 40 data migrations. The data expansion rate increases 5-fold. The data lake is designed to store mass and diversify data in a centralized manner at a low cost, and then mine data value through converged collaborative analysis. Considering the industry requirements, enterprises want a data lake with at least 3 features. Unified storage foundation. A desired data lake can provide large capacity and low-cost storage space while ensuring the data reliability. Unified analysis engine. It can support multiple analysis engines, provide unified metadata management, and implement cross-domain and cross-source collaborative analysis without data migration. Unified data management. The lake can centrally manage data lake infrastructure, visualize data and task scheduling, and provide intelligent operation and maintenance capabilities. After getting to know the requirements, let's see how we can build an efficient data lake infrastructure. Now, I'd like to share some of our practices and thoughts. Huawei uses a fusion data solution to demonstrate some concepts in the process. First, there is a unified storage foundation that supports storage of various data types. It is efficient and cost-effective and supports decoupled storage and compute for data analytics. Second, the data lake must have a unified analysis engine. It supports multiple types of computing, such as stream, batch, and interactive computing elements, collaboration between internal computing systems, and provides a unified interface externally to shield components. Third, unified data management capability. That is one management tool, one data catalog, and full lifecycle management. What are the features of a unified data foundation to better support massive amounts of data storage? The architecture. We believe the storage foundation of the data lake must be distributed and decentralized architecture. The metadata and data management capabilities can be scaled out, and the performance increases linearly with this capacity. Second, multiple protocols are supported for unified storage of various data and storage resource sharing. Protocol interworking prevents data copy caused by format conversion to improve the analysis efficiency. To reduce costs, I think we should start from the hardware and software layers. At the hardware layer, dedicated hardware is used to improve capacity, density, and performance density. And the automatic tiering function is used to build a high performance and large capacity converged storage pool. At the software layer, we leverage the erasure coding algorithm with high utilization. The EC algorithm has been put into commercial use for nearly 10 years in the storage field, since its performance and reliability are equivalent to those of the multi-copy algorithms. The EC is more suitable for the data lake with high utilization. The unified storage foundation must be highly reliable and support massive storage devices. But how can we ensure service continuity in the event of any hardware fault? First, to cope with the simultaneous failures of multiple nodes, a large number of nodes are divided into independent fault domains. We isolate faults from each domain. Therefore, each fault domain tolerates simultaneous failures of multiple nodes. Second, the system can be quickly recovered. The fault can be rectified as soon as possible through quick data reconstruction. Data read and write interfaces of common big data components are supported to decouple computing from storage in the big data scenario. After computing and storage resources are separated, we can independently expand capacity for precise investment. Computing and storage resources also pooled separately for auto-scaling, flexible scheduling, and fast service rollout. Stateless computing allows access from multiple computing systems and learn something from each of them. The data virtualization technology shields data attributes such as the format, region, and system and provides a unified view for users. The view provides one directory, one interface, and one copy of data. It lays a foundation for implementing a unified computing engine. Virtualization technologies have a promising future. Gartner predicted that 50% of organizations and enterprises will use data virtualization for their data integration by 2020, and that this figure will climb up to 60% by 2022. A unified analysis engine is able to provide converged analytics and directly access data of Hive, Spark, and interactive analysis engines. It can also perform association analysis and send analysis results back to applications quickly. This avoids unnecessary conversion and flow in a data lake and resolve the problem of cross-source and cross-domain analysis. A good analysis engine is efficient and easy to use. It can provide standard SQL interfaces, upward to connect to tools and applications for data governance, business intelligence, and visualization. The connector framework shields data source differences and connects to more than 30 data sources, such as Hive, HBase, Elasticsearch, and ChaosDB across regions. This implements unified interfaces, simplifies analysis, and further speeds up data application development. Finally, enterprises can be freed up from fetching data. The data lake infrastructure should provide management tools as follows. First, the management tools can monitor servers, storage devices, switches, Hadoop analysis software, and distributed database analysis software in a centralized manner to simplify the device management. Second, there is a unified data view for end-to-end visualization and SLA monitoring of tasks to accelerate analysis. Third, the tools equipped with intelligent O&M, capacity and fault warning, and fault auto-healing. They are able to keep learning and optimizing performance according to service running status. On and off cloud synergy simplifies operation and maintenance based on the intelligent prediction. It also helps tools learn from experience of others, making our devices easier to use. Huawei is dedicated to the platform plus ecosystem strategies and will keep investing in built data lake infrastructures to deliver the best to our customers and partners. We will leverage the data virtualization engines, interconnect data infrastructure with our partners and customers to usher in this intelligent world. We are ready to enable our partners and customers to quickly integrate data infrastructure capabilities to unlock data value. We are also pioneering in bridging analytics platforms of mass data with the standard data application schemes of databases to integrate the data lake and data warehouse. We will always keep our design philosophy in mind, taking on the complexity and making things more simple for our customers. Thank you.